Here's how to use continuous artificial locomotion effectively in VR. We finally made it to the last video in this series on VR locomotion. In this video, I'll be discussing the pros and cons of continuous artificial locomotion as a type of VR movement. I'll share some tips for using it effectively, and I'll also give you some of the best use cases for this type of locomotion. So let's get started. Continuous artificial locomotion is a type of locomotion that lets you move around in the virtual world in any direction continuously and smoothly, such as flying, skating, or driving. You use a touchpad, a joystick, or another such controller input to move around in virtual space, inducing that artificial movement. The good thing about continuous artificial locomotion is that you don't need any real-world physical space to move around, and it's much easier to move around virtual worlds and 3D spaces since you can move in any possible direction you can imagine. However, even though the concept of being able to move around freely in 3D space is very compelling and exciting, it is by far the most likely to make people sick. As I mentioned in my articles and videos about motion sickness, the reason for this is that there's a mismatch between what's being seen and what's being felt. Your eyes see that you're moving, but your body doesn't feel any motion. Richie's plank experience uses a combination of continuous artificial locomotion and real walking. You can walk on and off the elevator, and then the elevator closes and takes you to your desired floor. If you peek through the crack in the elevator doors, you can see that you're traveling upwards, but since you're only seeing a small sliver of movement, the risk of sickness is very low. You can choose to physically walk out onto the plank, but the fall is fortunately virtual. You make the choice to step off the plank, so you're the one initiating the movement. They make good use of careful, gradual acceleration speeds to reduce the risk of motion sickness. I highly encourage you to check it out for yourselves. I've included the link below in the show notes. I do want to note that there are more floors in this experience, such as the Hero Academy floor, which also uses continuous artificial locomotion. I can't use these floors personally since flying is the primary form of locomotion. And while they do let you initiate the movement, at the time I tried it, there was no other mitigation in place for sickness, so I didn't last very long. I won't try it again. And that's not what you want to hear from your audience when you create a VR experience. Coming up next, I'll give you some recommendations for mitigating motion sickness. I'll also talk about some of the best use cases for continuous artificial locomotion. But before that, like this video and let me know in the comments what your questions are about XR/UX design, and I may answer your question in a future video. Medical researchers are still studying what makes some people more susceptible to motion sickness than others. Once they figure that out, we'll be able to start creating better ways to mitigate that risk in VR. But in the meantime, I don't recommend this type of locomotion as your only form of locomotion, since you would be leaving out a large group of people who would not be able to enjoy your experience, including myself. However, there are many reasons that this would be necessary for you to use in your experience, such as flight simulators and racing games. And there are many people who prefer this method of locomotion and don't get sick at all, so I'm not saying to get rid of it altogether. That said, if you find yourself needing continuous artificial locomotion for whatever reason, there are some things that you can do to help reduce the risk or severity of motion sickness. Warn people if something might cause sickness, disorientation, or discomfort. Use head tracking and gaze to control the direction of movement. Keep people grounded with objects in the world and keep the horizon steady. Let people initiate and terminate any movement. Let people control their own speed of movement. Use care with acceleration and deceleration. Blurring the periphery is another option for reducing the risk or amount of sickness experienced, since motion in the periphery is one of the main causes of motion sickness. Provide options for comfort settings and alternative types of locomotion so that those who are more prone to motion sickness can still enjoy the experience. When it's necessary to move to a new virtual location, consider an elevator or a transport pod that blocks the view of motion, or other similar solutions that would work with the narrative. If there must be any instant location changes or rotations, consider using blinks that fade out and back in, since these are natural occurrences that our brain will already subconsciously fill in the gaps so that you don't even notice it happening. It does need to be used with care though, since overutilization of these features, such as with rapid changes 8 times per second or more, will reintroduce motion sickness. You can click on the screen right now to learn how to reduce the risk of motion sickness in VR. I hope you enjoyed this video. I'll see you in the next one.